Welcome back, Algebra 2 students. In this video, you'll learn about the absolute value parent function. We'll look at the equation and the graph and the characteristics of that. We're going to use Desmos. So in Desmos, if we want to look at absolute value, you can either type y equals, or we can use our function notation and type f of x equals. I'm going to start that over because it went away. Desmos.com. Graphing calculator. So easy to use. Very, very easy. Okay, so here's where you type your equation, and then the Desmos will do the graphing for you. So I'm going to do f of x equals absolute value. You've seen it. It's in the little bars. I'm going to go down here to this keyboard. This is absolute value right here. I'm going to put an X in the middle. We're going to use our right arrow to close the absolute value bars and hit enter. Okay. So this is the equation for the parent function absolute value. This is the graph. You can remember that graph because value starts with a V, and the shape of the graph for absolute value looks like a V. So there are some things we need to know about absolute value. We need to be able to identify the domain. Domain is the set of the x values. So we're looking along the x-axis. Okay, so we're looking how far left and right does this graph go. If you'll notice up here, this just keeps going to the left, right? So we have negative infinity, and it keeps going to the right, positive infinity. If you could zoom that graph in and see further and further and further, and it would just keep going and going. If you had the table, you could just scroll up and down and keep going. There's no limit to this graph left and right. It keeps going. This is called interval notation. Remember, we talked about interval notation, and you use a bracket if the number is included and a parenthesis if the number is not included. This is a parenthesis because you cannot actually touch the infinity part. Okay, this interval notation. Another way to write it is all values of x such that x is a real number. Actually, it would have this. X is an element of the set of real numbers. You probably are used to hearing that as all real numbers. That's set notation. We won't use that one very often, but you need to recognize it. Notation. Okay. The other way to state this domain is inequality notation. So we know this starts at negative infinity. This is inequality notation. What this means is that all of the x values, or the domain, all of the x values are between negative infinity and positive infinity. You would read it negative infinity is less than x is less than infinity. That's the domain. That's three different ways to say the domain of this function. Okay. What about the range? What is the range? The range is the set of the y values. So we're looking at the y-axis. What's the lowest y value in this function? It's 0. Notice if you look below the 0, there are no y values here, right? All of the y values are positive. So if I'm going to do interval notation, that 0 is included because this graph does touch 0, 0. It does go through the 0, 0. So when I use interval notation, use a bracket, it goes from 0, and the 0 is included. How far up does it go? To infinity. Can't touch infinity, so we put a parenthesis. That's interval notation. If you use set notation, this would be the set of all y values such that 0 all y values such that y is greater than or equal to 0. That's set notation. The set of all y's such that y is greater than or equal to 0. Inequality notation. 0 less than or equal to y is less than infinity. We don't need a bracket there. When you're working on your assignments through your online textbook, it's called Savas. You might accidentally hear me call it Pearson because it has been Pearson for years and now they changed it to Savas. When you work on your online assignments, very often they will tell you to write the domain or the range in interval notation. That's going to be using your brackets and your parentheses. But sometimes on the multiple choice answers, you'll see it in this set notation or the inequality notation. They all three mean exactly the same thing. The y values start at 0. They extend to infinity. When we did the domain, the x values started at negative infinity and go to positive infinity. All right, what else can we analyze with this absolute value function? We can talk about x-intercept and y-intercept. Remember that the x-intercept is where the graph intersects the x-axis. And the y-intercept is where the graph intersects the y-axis. You'll notice this graph intersects the x and the y-axis at the point 0, 0. And we're listing that point as an ordered pair with the x value first and then the y value. So the domain is negative infinity to positive infinity. The range is y is greater than or equal to 0. The x-intercept is 0, 0. The y-intercept is 0, 0. What else did we learn about analyzing these functions? Increasing and decreasing. This interval or section of the graph is decreasing. It's going down from left to right. We use the x values to describe this portion or interval of the graph. That is from negative infinity to 0. So it's increasing between negative infinity and 0. Scratch that, Mr. Dell. That's not increasing. What's it doing? It's decreasing. How do we know increase or decrease? You look at it from left to right, just like you're reading. Increase means going up, decrease means going down, so this is decreasing. Decreasing from negative infinity to 0. When you describe the intervals of increase and decrease, you don't put the lines underneath because when we get to 0, it stops decreasing and starts increasing. So you don't want to put the or equal to part. What about increase? Increase means going up. As the x increase, the y's increase. That's this interval. From where does it start increasing at 0? Where does it stop increasing at infinity? Okay. What else do we know about the absolute value function? We've talked about the domain, we've talked about the range, we've talked about the x-intercept and the y-intercept, and the increase and the decrease. Oh, one more thing, symmetry. What does the word symmetry mean? The word symmetry means the same on both sides, right? So let's erase this little line that I added and this little line that I added. This is your absolute value function. Is there a line of symmetry, a line that divides this graph into two identical parts? There is a line that divides this into two identical parts. And that line is this y-axis. That is your line of symmetry. That's called an axis of symmetry. The equation for that line is x equals 0. Okay. This function has reflectional symmetry about the line x equals 0 because all of these points are reflected across this x equals 0 line to make these points. If you take this point and reflect it across this line, it's here. This point reflected across here. This point reflected across here. This point reflected across. This point reflected across. Each point on one side, if you reflect it across x equals 0, it's going to be directly symmetrical. Okay, that is all your information on analyzing the graphs of absolute value functions.